Okay, so question 37 I explain, then question 38 you do. So your question is, what is the pH of a buffer? 21.5 grams of benzoic acid, 37.7 grams of sodium benzoate. So first, Henderson-Hasselbalch equation. pH equals pKa plus the log of A minus the concentration divided by HA. Next up, you've been told you have this many grams of your substance. Well, the acid is 122 grams per mole. Sodium benzoate, A minus, is 144 grams per mole. As such, you can get that down to the molar amount in each of the substances. So you have 0.26 moles of our change colour. 0.26 moles. And for your acid, you have 0.18 moles. However, what is also given in question 37 is that you have 200 millilitres of solution. So what that means is that if you have this many moles in this amount of solution, you need to bring this up to how many moles per litre. Therefore, you multiply both of these molar amounts by 5. You end up with concentrations of A minus being 1.3. You end up with your concentration of HA being 0.9. And then you can just add in the rest of the details. The pK of benzoic acid given, you should know it, 4.2 equals pH. And you should end up with a pH of approximately, if I double check, 4.414. Now do question 38. Change my location to do some of the other questions. Ignore that permanent marker, broken crap in the top left, please. For question 39, how to solve it is you need to ask yourself the question, when you add the new substance, what is it reacting with? And your choices are a base and a weak acid. So you're adding a strong acid, therefore it's going to react with the weak base. Second, is that going to have a Ka or a Kb? Well, if it's got a Ka, calculate the concentration change and then use Henderson-Hasselbalch. If it's got a Kb, convert to Ka using Kw equals Ka times Kb, then use that Ka to put into the Henderson-Hasselbalch and then work out your change in pH. Hope that helps. Okay, for number 43, what you need to do is pretty much the same process, but you're being given different numbers and asked to calculate something different inside the Henderson-Hasselbalch equation. So, still do the same things. First up, decide on the chemical reaction happening. Now what you have is something called pyridine and a pyridium ion being formed when acid is added to it. So the structure of pyridine is this, which looks like this in the skeletal formula, and when it combines with a H plus here, you end up with something that looks like this, okay? So, decide on the chemical reaction happening, we've seen it. Use the Kb of pyridine as a weak base and convert it to Ka using Kw equals Ka times Kb. Don't forget that Kw is 1 times 10 to the minus 14. Then, calculate your changes in concentration if necessary. Then, plug in your pH values that are given into the Henderson-Hasselbalch equation and work out the different put in the different concentrations here, and then you can work out the change in pH. So A was 4.50, that pH given, and you're looking for the ratio of these two things, okay? So you just need to use this value you calculated here in order to work out what the ratio is here. Nice and easy. Okay, so question 49 is kind of asking us similar questions to the big goal with regard to buffers, which is how do you make a buffer by getting the pH to equal the pKa? So you've been given this buffer in the beginning. You've been given 0.4 moles of this weak base, a weak base because it has lone pairs on the nitrogens, and 0.8 moles of this nitrate salt of the conjugate acid. You're given the Kb of this, so first you know that you're going to convert the Kb into the Ka by doing Kw equals Ka times Kb and rearranging the equation. So after you've done that, you've got your Ka value. Use the Henderson-Hasselbalch equation for the current pH. Then compare that to the pKa of this substance, the diamine. Then ask yourself, are you going to take the pH up higher? Then you add sodium hydroxide. That's what you've got to be in the mindset of thinking, oh, I'm increasing the pH, add sodium hydroxide. You're going down, you're making it more acidic, add hydrochloric acid. The reason we choose these two substances is that when these dissolve, the Cl- ion does not interact with anything in solution. It's happy and stable as it is, so we can ignore it. And the same with the Na+ ion, okay? Now, after you've done that, you know whether you're going up, adding base, or going down, adding HCl. Then you're asked, how many moles do you actually need to add? Well, you should work backwards. So what concentration of H+ is needed for the pKa equals pH value? Now, using the Henderson-Hasselbalch equation, we can see that we would need the log of A- over HA to equal 0. This means that the ratio of A- to HA must be 1. So that means that your concentrations of A- to HA must be equal. As such, you're starting with 0.4 moles of your base up here, and you're starting with 0.8 moles of your conjugate acid up here. And it's done nice and simple. What do you need to add to the substance to get these two things to be constant, okay, to be the same? So it's clear that you need to add something that is going to decrease HA and increase A-. So that's sodium hydroxide. And it's quite obvious that the number of moles needed to add would be 0.2, just because you need this to become 0.6 and this to become 0.6. I hope that helps.